geometry that represents the path of a sweep. Generally, that's what you do. It's not always, but in this case, for most of what we're going to do over the next couple of weeks today. There are many different types of springs listed here. Compression and expansion. From a modeling point of view, a compression and an expansion spring are pretty much the same. SOLIDWORKS does not apply forces to geometry. It does not pull or push. There are other programs in SOLIDWORKS that are used to simulate pressures and forces. But in a 3D environment, we purely create CAD just to represent the shape of the geometry in 3D space. That's the purpose of what we're doing. So we're going to do some simple and complex helix creation. We're going to do some basic 3D sketches, sweeps, planes, planar and revolved surfaces, 3D intersection curves, composite curves, and we're going to talk about 3D Peirce relationship. That's probably one of the only relations we haven't covered so far. Before we start the spring project, it's important to understand the fundamental differences in the designs of a spring. So many, many different springs. In manufacturing and design, there are literally thousands and thousands of different types of springs. But here's the few that we're going to work with. Compression and expansion, tension, torsion, composite tapered, and spherical. We're going to make an example of each one of these springs. I'm going to show you how that example could be used in a model environment. The different kinds of end conditions of a standard spring. There are 4 standard end conditions. The first one is an open-ended spring. And if you could imagine a coil of wire, which is what a spring is made from, being cut with a snip perpendicular to the profile path of the spring, that's what the end condition would look like here. It would just be cut off at 90 degrees to the wire. That's called an open-ended spring. If you did the same thing, cut off the spring and then ground the end by pushing it up to a rotary wheel or something that would create a flat ground surface, that's a condition that's known as open and ground end. And then there's the closed end, which is an open end where the wire, after it's been cut, is bent up until it touches or almost touches the next wire section. And then the last one is the closed and ground end. Same thing. You take an open end spring, you bend it up, and now this time you grind the bottom flat, usually to approximately half of the wire thickness. So we're going to look at that. So here's an example of a typical standard compression spring. And this could be a compression or an expansion. What's the difference between a compression spring and an expansion spring? Just whether it pushes or pulls, or whether there's forces in one direction or another. That's primarily what it is. In this case, we're working with a compression spring. And we're going to make it open and ground. It's one of the most basic ones. What is the purpose of grinding the end of a spring? Yes, to help it seat in its design environment. This one is a very basic version. You'll see there's some flaws in the way that the model is created for this particular one, but it works okay, so it's fine. So we're looking to create the model on the left. We're looking to create a feature tree that looks something like the one on the right. I'm going to do it a little bit different than that, but not a lot. It'll be similar to what you see there. So what we're going to start with is we're going to start with creating a helix. And to create a helix, in all cases, you need to define some information about the helix. And the first thing you want to define is, where does the helix start? Well, there are 2 things that determine the start of a helix. The first one is the plane where the helix will start from, and then the next is the rotational angle of where the helix starts. So the first thing I'm going to do is create a sketch on the top plane and create a circle in that sketch that is 0.5 diameter. So I'm simply going to just set it on there. Top plane, insert a sketch, circle at the origin, 0.5 inches in diameter. You can then use that to create a curve that is a helix or a spiral. And you'll get some information will pop up on screen. Let me just do something real quick there. I want to see if I can get rid of that. Yeah, that's kind of annoying the way they brought this up. And these are ways to modify individual pieces of the helix. In our case, we are looking for a helix that is pitch of 0.175, so it's a pitch and revolution is the type of helix that we're creating. It is a constant pitch, meaning it will not vary in its pitch between each circular coil. It's going to have 6 revolutions, and it's going to start at a 0 angle in the clockwise direction. Clockwise, starting at 0. One thing to note about starting at 0, if you are at 10 and you want to wind down to 0, you will find that you cannot do it. If you are at 355 and you try to wind up to 360, you cannot do it. You can simply type 0 and it will go in there. I don't know why that is. You'll see the preview updating. You see you can wind around to distance. So we've got 0 angle, pitch and revolution, constant pitch, 0.175, 6 revolutions, meaning it will circle 6 times before it terminates. The starting angle is 0, which is down here. If you look at the top plane, you'll notice that in SOLIDWORKS, when you're looking at an arc in a plan view, 0 is here at basically 6 o'clock. Where is it on most CAD systems? If you use Mastercam, where is it? Nope.
Let's see, AutoCAD it would be at 3 o'clock.
3 o'clock. It's always at 3 o'clock. You'll always see the 0 here.
But on SOLIDWORKS, it's 6.
It's at 6 o'clock. Never been given a definitive answer as to why that is, just that it is. So, once you create a helix, you now have a guide curve, or a path in this case. But now we can create geometry on the path. And to do that, we need to put a plane. Now, a lot of students will come along and they'll say, oh, since that's at 0, I can put my sketch on the right plane. And I'm not sure the tutorial tells you to do that or not.
No, they tell you to.
But generally, the correct way to do it, because if you look from the front orientation, you can see that that helix is coming off at a strange angle. So if you draw a circle vertical to the right plane, it's going to have this pitched over path as it creates it, and it won't create a true circular wire. So the correct way to do it is to create a plane that is normal to a curve. It takes a minute for this thing to come up. I'm going to, first reference is going to be the guide curve. Second reference, I'm going to say, put it at the origin here. And you will see that it will put it coincident to the origin, and it's saying perpendicular to the curve. You can also say, set the origin on the curve. That is referring to the sketch origin. Let's just look at that and see what it looks like when we create it. So we have a plane here. I'm going to insert a sketch. I'm going to draw a circle. Look at the way that plane is. If I look at it from the front, you can see it's not in alignment with the right plane. It's perpendicular to the curve, which is what we want. I'm going to draw a circle in space. And you'll notice the way I'm not trying to make it coincident with that sketch origin. Because if I try to put it there, it won't become coincident to the sketch origin, because it's an end of a helix. So, the way to do that is not to try and use a coincident relationship. This is basically a wire that is passing through space. That's what this is. Okay? And we want that wire at some point to intersect the center of our 2D circle. Remember, the circle is in a 2D space. It's on a flat plane. The curve is in a 3D space. So, I'm going to tell SOLIDWORKS to make that circle intersect with the curve. And that should bring them together. I'm going to use an option that SOLIDWORKS understands as pierce. What it means is set that helix to pierce through that point. So you cannot make a pierce relationship between two lines. You cannot make a pierce relationship between two arcs. It must be between an arc, a line, a spline, and either a vertex or a point. It has to pass through something that has no linear or cordial length. It is simply something that is a point in space. But we can see an issue here. What is the issue that we can see?
It's above the end point?
Yes. It is not actually at the end point of the helix. And there is a reason for that, and that is because if you were to take that plane and extend it through